Alright, so in this example problem, we're going to talk about how you can solve for the principal stresses within a um, given state of stress using MATLAB. So if you haven't done so already, you can create a MathWorks account on MATLAB online. So you don't actually have to download MATLAB onto your computer, which will save space on your computer, and it works pretty well. Um, so what we're going to do is MATLAB has a built-in function called EIG. So what we're going to do is we're going to define our state of stress, and we're going to plug it into the MATLAB function called EIG, and we can then use that to solve for what the EIG function does is it solves for your eigenvalues and your eigenvectors. So for the case of a stress problem, the eigenvalues of our stress problem would be the principal stresses. So it'll give us a matrix like this. It'll give us a 3 by 3 matrix where all the diagonals of our matrix are going to be our principal stress values. And it'll also give us our eigenvectors. So it's going to give us our directional cosine. So it'll give us a it'll give us a matrix of directional cosines that's going to be equivalent to our transformation matrix transposed. All right. So what we're going to do at the very end is to verify that it's correct. Is we're going to multiply our transformation matrix times our original state of stress times our transformation matrix transposed. If all of that works out, what we'll end up getting, we should get is uh, uh, our a stress matrix of just our principal stresses. All right, so we're going to log into MATLAB Online here, and we're just going to start making some of our codes here. So the first thing we're going to do is we're going to define our state of stress. We're going to say stress is going to be equal to our first row of our stress matrix was 311. So we're just going to type in 311, and then we're going to put a semicolon here. All right, so that's our first row. The second row of our matrix was 102. So that's coming from here. All right, so we're going to just type in 102. All right, and then our last row of our matrix was 120. So we're going to plug in 120. All right, and then we'll add an extra. So what we end up getting is that will be our stress matrix. Okay, so all right, the next step is we're going to solve for the eigenvalues of that stress matrix. So we can say, we're going to type in our function, which is going to be, our function is going to be equal to the directional cosines, and then the second argument that we're going to, I guess, assign is going to be our principal stresses. All right, so these are just variable names. You can name them whatever variable name that you want. And then we're going to set that equal to our eigenvalue of our stress matrix. Okay. So if we hit enter, hopefully it should run. And what we'll notice is that if we type in our directional cosines, what we'll end up getting is we'll get a 3 by 3 matrix. All right. One of the things that you could, and then the other thing that we can do here is we can have, we can find our, calculate our principal stresses. All right. So if we look at this directly here, these three values here is our eigenvector due to this principal stress. These three values here are our eigenvalues due to this principal stress, and this value here is our eigenvalues due to this principal stress here. Okay. So the next thing we're going to do is we're going to say that we're going to set our transformation matrix is going to be equal to our directional cosines transposed. Okay, so all this is here is we're going to just transpose the matrix on the top, so all the rows will become the columns and the columns will become the rows. So that's what this will look like here. So notice this is the same. This first row here is the same as the first column here, and the second row here is the second column here. The third row here is the third column here. Okay. So what we can then do is we can say that I'm going to say our principal stress version 2, all right, is going to be equal to our transformation matrix times our original stress matrix times our transformation matrix transposed. Okay? So, all right. So if we hit enter here, what we should hopefully get is our same matrix of our principal stresses. All right? And what you'll do is if you see our principal stress matrix here has the same principal stresses -2, 1, and 4 as our principal stress matrix here as well. So, in conclusion, if you can define your stress and you use the eigenvalue function in MATLAB, it's really simple to calculate what are your directional cosines and what are your principal stresses using this function. So it's a great way to check your work after you've finished your calculations by hand.